Hello and welcome to this quick demo of my Coursera peer review project, Harnessing AI and ML for Electrical Power Output Prediction. My name is Puneet Acharya. Let's begin. So, the objective of this particular project is to build an AI ML model, a predictive model for estimating the electrical energy output. So, as a part of this project, the data source that we have received is a CSV file with 9,500 plus of early readings from various sensors in a power plant. Now, the readings or the input features, should I say, that we have is temperature, ambient pressure, relative humidity, and exhaust vacuum. However, the output that we are trying to predict as a part of these input features is measured in terms of PE or megawatt, and it's also an hourly electrical energy measured in in PE. If you look at the readings, and we will see in the next slides, not all readings influence the output equally. There are some readings which have a direct correlation with the output. We will look that in the next slides. Now, this is a slide which represents two charts. The first one is the correlation between temperature to output, which is measured in terms of PE. And as you can see, that there is a direct relationship between the output as well as the input feature temperature. Similarly, for exhaust vacuum, as an input feature, there is also a direct relationship with the output, which is measured in terms of P. So these two input features are examples of good input features that can be used for predicting the output, which is measured in PE. There are other two input features also, which is provided as a part of the data set. There is pressure, which is AP, ambient pressure, and humidity, which is RH, relative humidity. So if you look at this, there is a high level of dispersion between the input as well as the output. So these are bad examples of input features if you really want to predict a model and have a lower error rate, which is again, we will see measured in terms of MAE or MSE. So the modeling approach that we took in this case was a supervised learning. The appropriate output metric in this case is MAE, which is mean absolute error, and we can also look at mean squared error. So both these units can be used. However, our preferred case was MAE because there were no extraordinary outliers as a part of the input features. And since there are no extraordinary outliers within the input features, we preferred the MAE error metric. Algorithm in this case, since we used Google for this, we used AutoML tabular regression. The validation set was a fixed validation set, and the data split, since we build around five different models. In some models, I used the manual split between the training set, the validation set, and the test set. However, in other cases, we used the functionality provided by the Google itself. So if you look at the first three models, which is model 5, which was an auto data split done by Google, and the features in this case we selected was AT, ambient temperature, and vacuum exhaust. In model 4, we also did an auto data split. However, in this case, the features which were used was AP, ambient pressure, ambient temperature, and vacuum exhaust. And in Model 3, which was also an auto data split, we used all the features. There were two other models that we did, which was manual data split with all features, and then there was another manual data split with weighted column 80. So we wanted to try different type of models and see what was the outcome. And if we can go to the next slide. So here is the output from these models. So if you look at version 1, which is again the model 5, in this case, the input features was 80, which is ambient pressure and vacuum exhaust. And this has the lowest MAE, which is mean absolute error when it comes to the outputs. So if you look at other models as well, so we have a list of various metrics in here. We have the MSE, which is root mean squared error. We have MAPE. However, the one which we are concerned in this case is MAE and RMSE. And if you look at these, out of all these models, the one which performed the best was Model 5 with two input variables, AT and which was ambient temperature and vacuum exhaust. With this, I'm gonna close my presentation. Thank you so much for listening.